Hello guys, Arnav here from Coding Box, and a really interesting thing has happened. So Google has deprecated Android's AsyncTask API in Android 11, and that's quite a big deal because AsyncTasks were a very popular paradigm with which people used to start concurrent programming in Android. Although as you grow as an Android developer, you start moving to using things like HTTP for network calls, and you learn how to use coroutines, etc. in Kotlin, and then your dependency on things like AsyncTask reduces a lot. For example, when I'm working on a big project like Zomato's app, I'm not really using AsyncTask for most of the things that I'm doing. But anyway, AsyncTask is something that every Android developer has used, has learned, and now AsyncTask is going to go away from Android. So we're going to take a look at something really interesting. Google has been suggesting that the appropriate replacement for AsyncTask is using coroutines. So how can we basically replace the exact functionality of AsyncTask? Like, for example, you have a project, it's a pretty old project and it has a lot of places where it is using AsyncTasks, right? You want to migrate that project to coroutines, but you don't want to change the code everywhere in your app, right? So what do? We're going to build an exact implementation of AsyncTask using coroutines, so that we don't need to use the actual Android AsyncTask anymore. So let's see, we have this little project. What it does is, it has this ready written here. If I give a number here, say I give 3, and I click on start, so it counts down from 3 to 1 and it says done. If I provide, say, a number like 5, it does count down from that. But if I stop it in between, it's gonna say shit. Okay. And how are we achieving this? We have achieved this using a counter task which extends AsyncTask in the 3 generic params, which is the AsyncTask takes 3 generic parameters. As if you have used it, you would know, params, progress, and result. So we have it uses integer params, integer progress, and string result. So do in background gets integer params, inside which we basically pass the number of seconds it is supposed to run. We decrement it and we make our thread sleep for 1 second every time, and we return done. Okay. So on progress update, we update the value of TV status. On post execute, we update the value of TV status. On cancel also, we update the value of TV status. Okay. So when button start is clicked, we create a counter task variable and we execute it. When button stop is clicked, we cancel the counter task that is running. Okay, so building something like this has its downfalls as well. So for example, if I click on start and I go away from my activity, and by the time it ends, my activity would not be on the main thread, and it would not be able to run. So there would be problems around that. So if I click on start and I finish my activity basically, right? So in this case, how would it basically run on post execute on my main thread? There could be memory leaks related to that, and if I stop the activity without the task having been created in the first place, there could be a crash related to that as well. So anyway, there are a lot of problems that AsyncTasks have. But what we'll try to do is we'll try to create something called coroutine AsyncTask. So let me just create a new Kotlin class called coroutine AsyncTask, and what I want is that I will be able to replace this as it is with this. So first of all, AsyncTask is an abstract class, abstract coroutine AsyncTask. It takes 3 generic parameters, params, progress, and result, as we know, right? That's how the AsyncTask is created. There we go. So this is the definition of AsyncTask. And while AsyncTask does a lot of things like thread factory and rejection handler and all of those things, we are not going to get into that. Let's just try to implement the end goal, what an AsyncTask has. So what are the functions we can override in an AsyncTask? What are the public functions that we have? Like if we do, so you see that there is, do in background, on progress update, on post execute, on cancel. There is also a function called on pre-execute. So and on cancel, which does not take any value. So we're gonna build all of these things, and we are gonna add support for these functions as well, the execute and the cancel function. So first of all, there's going to be the do in background function. So the do in background function is going to be of this nature. And it's going to be abstract because that's the one that people are going to be implementing. Then we're going to have on progress update, which is going to be of this signature, and this would be an open function. Okay, and anybody can come and override it if they want, but ideally it will have an empty value. Then we would have on post execute. Again, we will follow the same signature, open function for this type. Then we would have something for on cancel. Right, and we need an on pre-execute as well. So let me just keep that ready. On pre-execute, if we just want to implement this thing, so this is just going to be an empty function like that. So there we go. This is supposed to be an open function as well, so that people can override it. But there are going to be a few non-open functions as well. So there's going to be fun execute, which would be taking would be of this signature. As you can see, there is a fun execute which takes the var args of params, right? So it will take var arg params of this type, params, which would be array of type params. Okay, then we would have so here also this int would basically be of the params type, and this string would be of the result type basically. The on post and on cancel are gonna get result types. So this I'm creating it in a generic way. It should not default to using ints and strings, etc. This is gonna be of progress type, the on progress update ones, right? So this is gonna be progress, and this is gonna be varag param is gonna be of type params as well. Okay, so awesome. And there's gonna be a cancel function. So this cancel function takes some variable called may interrupt if running. So let me just take that may so what that means in AsyncTask we will see, and we will try to implement that as well. Okay, so when somebody first constructs my AsyncTask, and then what they will do is they would be basically calling execute. Okay, so when they call execute, I would do is I will actually launch do in background in a different thread, correct? So I'm gonna do, I forgot I don't have the coroutines installed in my project here. I'm going to install coroutine Kotlin. So I need Kotlin X coroutines Android. That's the library that I need. So it's available here, kotlinx.coroutines, and I think we would get a Gradle file for that. I think it will be org.jetbrains.kotlinx, something like that. Okay, how do we add this? So there will be a Gradle implementation line. Just see. Probably would be at the root of this folder in this GitHub repository. So ideally what we want in AsyncTask is that this function should get executed in the background thread, while this function on pre-execute, on progress update, and on post execute, all of this should execute in the main thread. Okay, there is another function that we forgot. This is publish progress. So there is a function called publish progress, which is of this varag progress type. So we are going to have this function protected fun progress that takes varag progress of progress type. Okay, so that's my publish progress function. So these three I actually have to write the code for, right? And these are the ones that users are gonna be overriding and writing their own code for. Yeah, so to get coroutines working, we need to implement this in our project. We'll go to apps Gradle file, include Kotlin X coroutines Android. So that's what we want. And okay, how are we going to handle this? So when somebody calls execute, what do? We do is we run global scope dot launch on dispatchers dot default. So we use the default dispatcher, and we call this function do in background, and we pass the params into it. So there's a problem that required params and found array or params. Okay, so this is an operator which basically is called the spread operator. It takes an array of parameters and it can turn it into variable arguments back again. Then what we're going to do is we will call do in background. When someone calls publish progress, we are going to have to call it into the main thread. So whenever somebody would be running publish, calling this publish progress function, we are going to do global scope dot launch on dispatches dot main, and on the main thread we are gonna call on progress update with the values of progress that we have gotten. So we will pass progress into it, and again we will spread it so that the variable arguments are passed properly. When somebody calls publish progress, that's execute. So let's just start off with this. If somebody starts execute, we basically launch this. We do this in do in background, and once this has been completely done, then we want to go back to the main thread and run on post execute, and we would run on post execute with the result of do in background. So I will take the result of do in background and pass it into on post execute right here. So do in background is going to run, it will provide me a result, and that result I will take and I will pass it into on post execute. Okay, so at this stage I think running it without cancelling it should start working. Let's give it a spin and let's see if it works or not. So I'm going to go to main activity, and instead of async task I'm going to extend coroutine async task, and it has a few things which we need to also implement. Is cancel, so there's nothing called is cancelled, so we can have is cancelled function. If there's a boolean function for is cancel, so let's add that as well. Just hard code this for now, so we will have fun is now. If you want to use it in Kotlin the exact same way, we can do var is cancel, and we can have a get function. So it will always return or we can just write it like this: var is cancelled equal to false, right? And this is supposed to be protected as well. So we would always get is cancelled with the value of false. So let me just go to coroutine async task again. So if is cancelled, return shit. It is never going to be cancelled because we are not having the cancellation property right now. And in this stage, if we just run this, let's take a look at how it pans out. Okay, so there we go. So let's pass something like 4, and let's start. So 4, 3, 2, 1, and done. So this works exactly like like a async task is supposed to work. Although, like if I pass 4 and I click start, and it has started, and at that stage if I finish my activity, we may get some errors here because the main thread was not running to be able to execute that. But anyway, roughly we have got our basic stuff ready here. So so this is an implementation of AsyncTask. Now, as you can see, I can simply change the class that I'm extending. I can simply change it to coroutine AsyncTask, and I don't need to change anything in the implementation. I don't need to change anything in how I'm using it. It works exactly the same way. So you can build something exactly like Android's AsyncTask, which implements coroutines. Of course, this is not really the finished product because there is a lot of error handling and memory leaks which we need to take care of, and we don't even have the cancellation part done yet. I would suggest that if you want to try out how to build the cancellation yourself into this, you'd have a lot of fun trying to build that. Okay. So I hope that gives you a good bit of idea about how to use coroutines in instead of traditional thread handling that Android has been doing till now. Okay.